It is that time again. Just FYI, due to some technical difficulties that happened yesterday in the stat class, I had to move their 10-2 homework to next week. Okay, so I don't do one thing in one class and not one thing in another, so I'm gonna go ahead and take your 10-2 and move it to next week as well. We're still gonna go over it today. Okay, so that buys you a little time on your 10-2, but just to let you know, okay? We're still gonna go over it, but it's just due in a week. Okay, so be looking for that to move probably in the next couple of days, but it will not be due on Sunday or whatever, okay? I'm going to move 10-2 to Sunday of next week. Okay? Now, nothing's getting moved next Sunday. It's gonna look like you have a whole bunch of homework, so if I were you, maybe go ahead and do 10-2 this week, but it's gonna buy you a little bit of a buffer. Real quick, let me pull up your. We'll make sure that we're kind of staying on schedule here, so everybody kind of knows where we're at. Because man, we are close to getting done this semester. Do. Obviously, today's last day to withdraw, so if you're not feeling very well about this class, you talk to an advisor or somebody about that. Okay, notice that this week, your chapter 8 is due. Okay, so be ready for that test coming up next week. Okay, that'll be your last chapter test there. Yep, and like I said, I'll be moving this 10-2 to next week. And then don't forget about that 12-1, 12-2, this due right there at the very end. Hawks will shut down on 10-4, okay? Not 10-4, I'm sorry. On May 4th, at midnight, Hawks, it is done. So 12-1 and 12-2, you will not have an opportunity to do those late. Okay, so I would make sure to get those done. There's your critical thinking, that is due on the 30th. That module should be open already, well, it is open. It should be where you can turn it in to me through there. If you get it done early, you can turn it in online. If there's not a way to do that, email me and I'll make sure you can do that. So, for those of you in the ITV world, I will have it open. I will make sure to change it where you can turn that into me online through paper. Just scan your paper, take a picture of it, or scan it as a PDF. All is well. Are we good? See where we're coming at? Okay. And then, of course, your final for this class looks to be 8:30 to 10:15 on Monday. We can double check that very quickly. Maybe you need to know this for all your classes. Here we are right there. We're at Tuesday, Thursday, 8:30. There it is right there, yep. So your final, during final week, we will meet in this class on May 5th. Okay, at 8:30 in the morning, and you have till 10:15. I don't know exactly how it works for ITV, if y'all will come at the same time, but if not, you'll go to your normal proctor time. It's going to be in Hawks, and then I will be sharing a password. Okay, so you'll just log into the Hawks system, do your work there, and then you can, for you people in here, you'll just give me your work. For those in the ITV, they can just email me their work. Good. We know where we're at, where we're going, where we've been. Let's get started. We've been doing hypothesis testing. Okay, the fundamentals of hypothesis testing. Okay, I'll kind of get through the very first of this. Okay, notice I said a hypothesis is a theory or premise. Often it is a claim that someone is making that must be investigated. In science, a hypothesis is usually a claim about how the world works. In statistics, a hypothesis involves a claim without the numerical. Involves a claim about the numerical value of a population parameter, such as population mean, proportion, and variance. And that's exactly how this lesson is going to go. Okay, in chapter 8, I taught you about, okay, how to take those tests that we did, right? And then we learned how to do it with mean, sigma known, sigma unknown. And then you learn how to use the student's t distribution. And then we did it with proportion, and then we did it with variance. Same thing's going to happen here. I'm going to give you a concept. This is what the hypotheses are. This is what we do with them. This is how we do it. And then you're going to go on from there and go, okay, how do I do this when sigma is known? How do I do this when sigma is unknown? How do I do it with a proportion? How do I do it with variance? And there you go. Okay. And that's exactly how your final is going to go. Is it's literally going to say to you, hey, you have a hypothesis. And then you have to decide which test am I going to use? Just like in chapter 8, I said, hey, which interval are you going to use? Which critical Z, are you going to use a critical Z value? Are you going to use the t-score? Are you going to use proportion, that 1 minus prop Z interval? You know, how are you going to create your interval? You just got to kind of subdivide in your head what you're going to use. So how do we do it? Hypothesis testing is a statistical process for determining the likelihood that a given hypothesis is true. And I'm going to put that word true in parentheses right now. You'll see why shortly. So the procedure, you are going to state the null and alternative hypothesis, which I'll go through very quickly. Like I said, you're going to kind of review. Those of you who were here the other day, you're going to review. Those of you who weren't, because I know you had to be some school thing. This is going to be kind of new to you, but I'm going to hit it kind of fast. Then you need to determine which distribution to use for the test statistic. That will come in 10.2 and on. Gather data and calculate the necessary sample statistics. The gathering of the data, you don't got to do that. Hawks is going to do that for you. They're going to give you data they collected, but then you're going to have to do the math. Okay. And then after that, you have to draw a conclusion and interpret the decision. Okay. Basically, what that's going to come down to is, do you believe what everybody else says, or do you believe what your hypothesis says? Okay. And I say the word believe. Once again, I want to use all these terms in quotations because it makes it a lot easier. Continuing on. And then probably one of the most important things you're going to learn about this lesson is this. State the null and alternative hypotheses. So once again, the hypothesis testing is a statistical process for determining the likelihood that a given hypothesis is, I really hate that they keep using this term, true. Okay, you'll see why shortly. But then we've got some terminology here. Alternative hypothesis, denoted by H sub alpha, is a mathematical statement that describes a population parameter. And it is the hypothesis that the researcher is aiming to gather evidence to support. It is also referred to as the research hypothesis. I'll help you out with that a little bit. This is how we're going to define it. What I think is a little easier way to define it is this way. This right here is a belief you're challenging. Okay. And then you also have the null hypothesis, denoted by H sub 0. It is the statement that expresses the value currently believed to be true. It will always be, and you need to remember this right here, always be a statement of equality. Okay. When I get you an example, you'll see what that means. Okay. This right here would be the current belief. An example is what I'm going to use right here next. Reading this very quickly, let's face it, many of us consume too much added sugar. Adults, young adults, and children in the U.S. consume on average 17 teaspoons of added sugar every day. To the class the other day, that is 1 Dr. Pepper. Okay, 17 grams of sugar every day, more than 2 to 3 times the recommended amount for men and women, respectively. This adds up to around 60 pounds of added sugar consumed annually. That's 6 10-pound bowling balls, okay, of added sugar that you are eating per year. Okay. Notice it talks about mean. Now, this one, you got to be careful on your homework because they may not always be dealing with mean. They could be dealing with proportion. They could be dealing with variance. They're just kind of getting you ready to be able to have to start looking, okay? So notice we have H sub naught and H sub alpha. H sub naught is, I'm just gonna start calling it the null hypothesis. Okay? That is the commonly held belief. Okay? So here we would put it this way. Our HO is going to be the mean is equal to 60 pounds. That is the belief. The common belief right now is that people in general consume about 60 pounds of sugar extra annually per year. The alternative hypothesis would be this. Now notice there is not anywhere where it says greater than or less than. If you don't see that, it's always this right here is going to become a mean, and it's going to be not equal to 60 pounds. That's important. That is going to be very important moving forward, especially on your calculator work that you're going to start doing. And I did double check. Those of you using a TI-83, your calculator does do the work on this. Okay. Now let me give you some little help. In 10.1, you have to fill in everything. Okay. Good news is in 10.2 and on, they fill in most of the work for you. Okay. But remember what it says. It says the null hypothesis is always a statement of equality. So this symbol there will always be an equal sign. Always. Okay? Because if it wasn't, then your job is to try to prove that statement, and that's not your job to prove their statement. Your job is to prove your hypothesis, which is the alternative hypothesis beneath it. Okay? If you're dealing with a mean on top, you're dealing with a mean on the bottom. Those will always match. If you're dealing with 60 pounds on top, you're also going to be dealing with 60 pounds on the bottom. So notice if you find the mean, you've got the mean on the bottom. If you're dealing with mean, you're going to be dealing with mean on the bottom. The top operator sign is always going to be an equal sign. Now, the only thing you've really got to look at moving forward is what is this guy going to be? Right there. Okay? And finding out, is it less than? Is it greater than? Is it not equal to? So far, so good? Okay. Try one. Determine the null and alternative hypothesis for the following scenario. The null will always come first. Okay, you always state what the common belief is, and then you say the alternative. Okay. After learning that Peter Cole out of Switzerland could hold his breath for 19 minutes and 21 seconds underwater, a group of students decided to conduct their science fair project around the amount of time an average adult can hold their breath. And I would tell you that you're probably going to be dealing with mu because that deals with mean. Okay. Part of the group found research to suggest that adults can hold their breath for 30 seconds when submerged in lukewarm water. The other half of the group found evidence to suggest that the mean time is different if the water temperature is colder. The group would like to test this claim about adults holding their breath in cold water. Okay. I'm going to give you this. Parse it out. I know that I'm going to have a null. I know that I'm going to have an alternative. I do realize they're talking about mean. Okay. So I'm going to go ahead and put a mu here, and I'm going to put a mu there. Okay. I also know, just from what I've told you, is this. I know the null is always going to be a statement of equality. So that can immediately just happen next. Okay. But now what number should I put now? Exactly. 30. 30 what?
Seconds.
Stay. Exactly. 30 seconds. The common belief consensus is saying that the average person can hold their breath for 30 seconds. So knowing that I put 30 seconds in one, I can immediately go ahead and say, hey, I'm going to put 30 seconds in this one as well. Because everything else has to match, except for what's happening now. Now, is it going to be less than, greater than, or not equal to? Not equal to. There was never anywhere in there that they specifically said less than, like people can hold their breath less than or greater than. They just said what? That this says different. Different's kind of vague. So different just denotes that. Now, they did try to probably trick you a little bit because notice they talked about lukewarm water and then this temperature is colder. Okay, but notice that was never really the specific thing that we were focused on. That was just some extraneous information that they were trying to throw you off their scent. Okay. Good so far? Okay. Usually the hardest part of this is sometimes finding the right operator symbol. Okay. Let's do another one. A leading news authority claims that the governor's job approval rating has dropped over the last 3 months. Previous polls put the governor's approval rating at 56%. The governor's chief of staff is concerned about this news report since it's an election year and he wants to run a test on this claim. So we have, once again, we have a null and we have an alternative. But now what am I dealing with? Percent. Well, what's a percent? Proportion. How do we denote proportion? With a P. So this, instead of a mu, is now going to become a P symbol. Okay? And without knowing anything else, what can I put right next to the null immediately? Equal sign. Every time. It's always going to be equal. Okay? Even if they don't say anything in there, they may just be telling you about the alternative. That may be the only thing they talk about. Doesn't matter. The null is always an equality. Okay? Well, what are we trying to say here? What's that going to be? P is equal to what? 0.50. Yeah. For right now, I'll just put 56%, but you're right. It's going to depend. I think in Hawks, they're going to want you to put that in decimal form, 0.56. Okay, but now what though? I will say this. Can we all agree that you could immediately do that? Yeah. But now the trick is, now what? Is it not equal to? Is it greater than? Is it less than? Is there anything you can parse out of that?
Less than,
Why do you think that?
because it says the rating has dropped.
Very good. There you go, right there. That dropped. Okay. Says that. But notice you have to be like a little bit of a detective sometimes. Okay. Now I'll be honest with you. How this would actually work in the real world is you would know your hypothesis. Okay. Right now you're learning how to look at them, but to be honest, here's how this would work in the real world. You're looking at something and you hear something on the news and it says a commonly held belief of something such and such, such and such. And you're like, that doesn't sound right to me. I don't think it's that number. I think it's greater than. I think it's less than, or I think it's not equal to, okay? And so therefore you have now developed your hypothesis. And then you would say, okay, this hypothesis, well, what am I going to do with it? Am I going to be looking for the mean? Am I looking for a proportion? Am I looking for the percent of things? Or am I looking for the variability in something? You know, so that's when you're developing your test statistic. What are you going to do? Then at that point, you would go try to find data. Okay. You don't gather data and then make your hypothesis. Okay. Because if you do that, you're making your hypothesis on what you stared at. Okay. You need to go ahead and make your hypothesis, gather the data, and then see if the data agrees with your hypothesis. Okay. But that's part of the process. And then step 4, you have to make the conclusion. Did I make the right choice? Now, that's where you got to start being very careful. Okay. Because as you'll see, I've been saying the word true in quotation marks the whole time. Okay. So remember right now we've been developing our hypothesis. Then after that, you would of course decide on that. Which test statistics? These are all of them that you've learned, right? Here's a question for a good review. Let's do 2 copies of review here. How would I use that one? What needs to be, there's an essential thing that has to be part of that one for me to use that one. What about it? Huh? You're right, it's standard deviation, but what about it? Standard deviation is known. Remember that? That's the one that the population standard deviation is known for that one. 8.1, exactly. Go, yeah. I'm serious. That's how I passed this class. I'd always remember, where did I learn that? Where did I learn that? Okay. What did that stupid professor say during that lesson? Okay, I remember where to go to. I can now find it on the formula list, and then that jogs my memory on what calculator button to use. Okay, so here, sigma is known. Anybody remember what calculator button? However, calculator, but you gotta remember the button. That's the problem. B. Interval, remember that? It's too late, I already played it. You can't start saying it now, I already played it. Okay, well, if you were gonna use the student's T distribution, what about this one that you need to know about? Are we still dealing with sigma? What about it now, though? Sample, but what about actual population sigma? It's unknown. You should know I'm dealing with population because what symbol am I using? Am I using Greek or am I using a variable? Remember, Greek is always what? Population, okay? Remember, don't forget, S is sample standard deviation, okay? This is good review right now, okay? So what button could I use on my calculator for that one? If it's not Z, what could I use? Very good, you can use your T interval. And then the other two, once again, you're dealing with proportion. What's a good little kind of idea that you're going to be using it's not always there, be honest, it's not always there, but what's a good little telltale sign you're going to be dealing with proportion? A percent symbol's in there, okay? So maybe look for that. Hopefully that helps you out a little bit. What is your calculator for that one?
One minus.
Minus. No, oh no, yeah.
Prop zero.
Very good, prop Z interval. Can't remember it, maybe get it onto a note card, right? Have I given you those note cards yet? Okay. If somebody will, did I? How do you have one and no one else had?
I was given one last time I was here, I don't know.
That is true, I only like him, the rest of y'all can fail. No, I'll give, remind me and I'll bring those to y'all next class and y'all can start putting all your stuff down on them. Okay. What about the last one? What calculator button? Trick question, it's chi-squared, gotta use the chi-squared table, remember that one, we just did that one in 8.5, okay? And that's the one whenever it's dealing with the variance, okay, that's the one that says, hey, such and such manufacturer is looking at the variance of something, okay? Good to go on that? That's good review for chapter 8 right there. Okay. And what's nice, if you have all the calculator buttons, you really don't need any of those Z scores, because remember, that's for if you're deciding you're gonna go, I'm gonna go ahead and standardize this and then do all the math. Now, to be honest, on your projects, you're gonna need those formulas on your projects because you're gonna have to standardize things and draw them on your paper, okay? Good? All right. So that was step 3. Step 2. Notice we have this level of significance, that's that Greek letter alpha. Okay, that's your confidence interval. The confidence interval was 95%. That was your C. Remember, 1 minus C gives you that alpha. You got to worry about the tails. Okay, just kind of review for that. Then we got here definition, hypothesis testing terminology. A test statistic is the value in a probability distribution used to make a decision about the null hypothesis. If you started on your project I think that's question 1 or it's something around. There's 1, 2, or 3, but it's in there. Okay, that's your test statistic. A sample statistic is said to be statistically significant if it is far enough away from the presumed value of the population parameter to conclude that it would be unlikely for the sample statistic to occur by chance if the null hypothesis was true. And then level of significance, denoted by the A. Notice I just told you what that is. That's the 1 minus C. So they say you have a 95% confidence level. Remember that? You did the 1 minus, take that number divided by 2, you got tails. There you go. That is going to be very important. Sometimes. Okay, sometimes they're going to go ahead and give you a number. Sometimes you're going to have to calculate the number. Okay, so just kind of be ready for that. And then step 3, we're going to start gathering into the data, and then we're going to do the necessary things. And here's where this is important. Throughout the hypothesis test, the null hypothesis is assumed to be true. Now, once again, this is just for moving forward. This is concept, but I need you to know that when you're doing a statistical test, even if it's later on in your life and you got a job and your boss says, hey, go find out that this is true. First off, I need you to realize in your head, you always presume the null is true. Okay, like if I said to you, hey, tomorrow this star is going to die, and you go, I'm going to prove him wrong. Fine, prove me wrong statistically, but for right now, you got to assume that it's true. That's how come that's an equality statement. Okay, you have to assume it's true. And then does the data decide that later on? Properties, conclusions for a hypothesis test. And this is usually where I've had students email me and go, what does that mean? You're going to do 1 of 2 things. Only 1 of 2. You're going to reject the null hypothesis. Okay? Or you're going to fail to reject the null hypothesis. Which that basically states what? The null hypothesis is what? Do this when you say the word true. Because look at the next statement. No matter what the conclusion of the hypothesis test, neither hypothesis has been proven to be true. Well, then why do it? Because what you've done is say this. You have a null, you have an alternative. You do all the stuff. If you reject the null hypothesis, first off, you're saying, once again, see my quotation marks, you're saying the null isn't true, right? But you're not. All you're saying is this. Statistically speaking, there's a high probability that that's not true. But remember what you've learned about probability. In this class, is there such thing as really truly a 0 probability? Not really. Everything, just because it's really near 0, it's still not 0. So that's what's being said, okay? If you fail to reject the null, that means you're saying, this is true now. No, it's not. We're saying your alternative hypothesis has a high likelihood of not being correct. And so you have to agree with the consensus. It doesn't mean it's not true. It doesn't mean it hasn't been proven. It's just that you don't have the statistical probability for it to be true. Doesn't mean that he can't come along later and go, hey, I'm going to do that test again. And maybe something else happens. New data, more data, better testing, something, and things can change. Okay. Remember, you're in statistics class. This is not a physics class. You're not creating laws. Okay. You're just doing the likelihood of something being true, but you really don't know. Okay. There's just high likelihoods and low likelihoods. To help out a little bit, as far as concept, a little bit. I get it. If you're a statistics person, that's the thing that usually drives people up the wall. They're like, so nothing's ever really true. Yeah, but you know what? If there was 100 sandwiches and someone told me there was a high likelihood that I was going to catch, food poisoning from one of those sandwiches, I know that that's not 100%. But am I likely to eat those sandwiches? Probably not. So notice, while it's not 100%, probably still not going to do it. So I still will bend to statistical reasoning. So look at this right here. what are we getting to? We gotta finish the concept. Okay? Because in 10, 2, 3, 4, and 5, how things are gonna be moving is you're gonna have to say, hey, I'm now gonna decide, is this statistically feasible? Or is my hypothesis basically bunk? Okay, so look at this right here. The campaign manager for a gubernatorial candidate believes that her candidate connects with a younger audience and will draw a larger voter turnout for the 18 to 24-year-old demographic. Okay? Historically, sounds to me like a commonly held belief at this point. Only 25% of eligible voters between 18 and 24-year-olds vote in an election. A hypothesis test with a 5% level of significance is performed on the manager's claim. The result is to reject the hypothesis. Does the conclusion support the manager's claim? Okay, first off, always, you need to know your null. You need to know your alternative. What are we dealing with? Mean, proportion, or variance? Proportion, because the telltale sign was the percent sign. So notice, there you go. P and a P there. And I automatically know what's going to go here. Equal sign right there. Very good. What's my number? What number am I looking for? 25%. Okay. All right. But now what? I know the 25% can go down here as well, right? But now what is it?
Greater than,
What do you see that at?
because she believes that the candidate will draw more voters from a younger.
Yeah, look at that. Draw a larger voter turnout. So there's that. Okay, so we have our null. And now we have our alternative. Okay? So look at it this way. A hypothesis test with a 5% level of significance is performed. The result is to reject the null hypothesis. Does this conclusion support the manager's claim? Okay, we'll look at it this way. What's my alpha? Remember, you have a level of significance. That's always like a 95 and 80% or something like that, right? Your alpha is always 1 minus that, divided by 2, roughly, right? Would that be it right there? Yeah. Okay. Well, let's look at this. Is 0.5, is it greater than 0.25? Yes. Okay. So, what do you think? Does this confirm the manager's claim? Yeah. Exactly. That's exactly what it says. It confirms it because that number is greater than. Okay. So you would say yes. This confirms. This confirms yada yada yada. That manager's claims. Okay. That hypothesis test, you're going to be looking for that number. That's the number you're going to be comparing everything to. Now, what's good moving forward, and I only show you one way. I'm going to put a special video down next week on how to do it the picture way using a Z-score. That's going to help you on your project. Okay. But what's good is you're going to be doing a thing called a p-value. And here's how hard it is. First off, it's all calculator work. You're gonna like me for that. And all you do is go, hey, is that P greater than that? Yes. I agree. Is that P less than? Yep, I don't agree. It's literally gonna be 1 to 2. Okay. This right now is just saying, hey, take that level of significance there. That's that 5%. Yes.
Where'd you get that 0.5?
It's 0.05 on that. Yes.
Okay.
Sorry. Good on that one? There's a problem. Okay. And I'm gonna draw you a little chart Okay, it's gonna be in your notes. I'm gonna download all the notes today. But I'm gonna draw it really, really quick for you. In this lesson and this lesson only, and I am benevolent, it's not gonna be on your phone because it's kind of weird. But it does need to be stated. Okay? You can have problems with those levels of significance because you're gonna have people say, well, how come we just don't do this with like a 99% level of accuracy all the time? Why do we do 80%? Why do we do 85 or 90 or whatever? Okay? One problem, money. Remember, the more your level of confidence, the more people you gotta have to take a survey from or whatever, that costs money. But two, there's inherent mathematical risks that could happen, okay? So look here, we're gonna just do a quick little graph here. Okay, and here we're gonna say the null is true. Here we're gonna say the null is false. Here we're gonna reject the null, and here we are going to fail to reject the null. This right here on this side, this is your decision. What did you decide to do? This up here is called the reality. Now, to be honest, guess what's going to happen in the real world? Most of the time, you don't know what actually happens in the real world. You're never going to know, okay? If you reject the null hypothesis and the null hypothesis actually becomes true, you have what we call a type 1 error. If you reject and it's false, you just did the correct answer. If you fail to reject and it's true, then here you have a correct answer. And then so on for the next one, you have what we call a type 2 error. What does this say? As your alpha decreases, that beta, okay, probability of failing to reject a false hypothesis, okay, increases. As alpha increases, well, what do you think is going to happen to beta? It decreases. This is all it's saying. And yes, if you took like a master's level math class, they would give you more probabilities on what you're doing. Right now, we're being very general. But what it's saying is this, as my alpha level, okay, as it decreases. Now remember, as alpha decreases, that means I'm at that level of confidence that I had, that's going higher, okay? So if I have like a 99% confidence level, okay, that means I only have like a 0.05 level of significance. That's that alpha. So as that number decreases, okay, my beta increases. That's the probability of failing to reject. Well, the problem with that is as that probability goes up, then you have a possibility of running into an error, okay? And that error is basically saying, hey, there may be some inherent problem in what you're trying to do that you can't see, okay? Like maybe a confounding variable popping up. Okay, or something else, because what's happening? You're having more and more and more people. And so something could come in and infect that sample. Well, then you go, okay, well, fine. If that's going to happen, how about we go the other direction with it? Well, then the problem is what? You do too few samples. Well, then what happens? You have a more likely of a chance of saying that the null is true when it's actually not, because you didn't allow enough samples. So it's a give and take game, which to be honest, you're never gonna know if you do statistics. You just kind of got to go with the math and hope, which is why usually most of the time they do more than one statistical thing. So let's look at an example of one of those. Then we'll do a couple of homework questions, and then we're gonna get into 10-2. A television executive believes that 99% of households in the United States have at least one television, okay? An intern at the executive's company is given the task of using a hypothesis test to determine whether the percentage is actually less than 99%. Okay? The hypothesis test is completed. And based on the sample collected, the intern decides to fail to reject the null hypothesis. Let's stop right there before we go any further. Okay, we'll stop right there. Can we all agree, and I'll do this kind of quickly, I've got a P that's equal to 0.99, right? I know I'm dealing with proportion because I see a percent symbol in it. I know that's gonna be a P, that's also gonna be a 0.99. Okay, is that gonna be less than, greater than, or not equal to? They tell you. Very good, right there with that, less than, right there. Okay, now, read what it says. Very quickly, I'll draw this right here. Okay, we're just gonna put type 1. Correct. Correct. 2. HO is true. HO is false. Here, we're going to reject. And here we fail to reject. Okay, remember, this side right here is the decision. This side up here is the reality, which Hawks will give you the reality. In the real world, you're never gonna know the reality. Let's be honest. If you knew the reality, that means you knew the population, then why'd you do the statistics to begin with? Okay, but notice it says, if in reality, 96.7% of households own a television set, was an error made, and if so, what type? Okay, look what they say. First off, was the null false? Yes, it was less than. Okay, it was. It flat out said, let me do a little highlight right here. It did say false. Because the reality was this, the reality was 96.7. It was not equal to that. That's a false. Okay, now what did the person choose? Look what it says. It said they did what?
Failed to reject.
Well, that's right here. And that's where they match up right there. So that person chose to fail to reject the null hypothesis. That means their test said this, hey, I think the null's true. Quotations. But in reality, what actually happens? The null was false. And so there was an error in that statistical problem right there. And so, like I said, by using the little chart, you just kind of read it out. You're going to need to know the null and all of the alternative, right? But then you come in there and go, okay, where do they match up at? And that's going to be your answer every single time. Kind of good with that one? Probably practice a little bit, okay? It's only a few questions on your homework, so don't stress out on this one too much. And guess what? It is not in your final, okay, at all. But this is in your project. Look at question number 9, 10 or 11, I think. It says, could you have made a mistake? Right? Doesn't it say that very last one? I think Miss Wee, you've got your question out. What does the last question say? Or something around there.
Is it possible you made an error?
Yeah. This is it right here. Is it possible you made an error? Okay. So. And that's exactly what you would do. Right. There's some other questions on here. I'll leave them. I'll be downloading the notes today. They're all just homework help. There's about 3 or 4 questions. Today I'll be downloading the notes, and then tomorrow I'll download all the lecture videos as well. Let's jump in and start actually doing these tests and actually show you how easy it actually is. Okay? It's not as bad as what you're thinking. Really, honestly, the hardest part, figuring out the null and alternative. Okay? After that, if you get that, your calculator does everything else for you. Okay? Look at that. Hypothesis test for population means sigma known. So sigma is known for this. Okay. Once again. State the null and alternative hypothesis. Remember, we are gonna have to come in here and find out what is our null. What is our alternative? On a lot of these, and I do believe it's this way on your final, on some of them, it's actually gonna give you the null. Flat out. It's gonna say, hey, this is gonna be P equals this. And then all you got, and then actually on the bottom, it's gonna give you a P is something else, right? Hey, all you gotta do is come in there and go, is this going to be greater than, less than, or not equal to? Okay, which is kind of nice. It is important now that you start understanding the less than, greater than, or not equal to. That's going to become very important because your calculator is gonna ask you. Okay? It's gonna say, hey, which one is it? And if you tell me, I'm gonna help you. Okay? So. Once again. Going back, you have some tests. You have to decide which one you're going to use. Right now, for this one, we're using the mean sigmas known. Okay, so you'd have to go back and look at the z-score for that one when you're drawing on your project. If you're not drawing on your project, you don't got to worry about that right now. Because like I said, here in just a few minutes, you're going to need to use your calculator. So if you have a calculator, go and get them out because you're going to need them here very shortly. Okay. Once again, for this one, there's if you're using your z-score and you're using this for your project, there is how you would find the z-score. Okay. You need to make sure that if you're doing this in the real world, you need to make sure all your sample statistics work out. Make sure you're doing a, remember, greater than 30, stuff like that. After that, we're going to gather data, calculate the necessary sample statistics, okay? Same thing as before. And then we're going to come here and we're going to draw the conclusion. Are we going to reject or are we going to fail to reject? Remember, what do we have to assume to be true from the very beginning? Huh? The null. Remember, the null is assumed to be true because the null is always going to be a what? An equality. It's always an equality, okay? And then you have to make up your mind on what's going to happen after that, in which case I'm going to give you some definitions now. Now we start drawing. You're going to start having what we call rejection regions. Rejection regions are what you're going to put on your project paper. I need to see the drawing of the rejection region, okay? On your test, you won't be doing that. You're just going to be giving me a numerical value, and your calculator is going to, well, you're going to look at a number on your calculator and then make a decision, okay, by looking at another number on your test. But here's what we have here. Alternative hypothesis. You need to remember this because your calculator won't tell you, okay? So notice, alternative hypothesis. If it's H of alpha, if you're using a less than, it is going to be a left-tailed test, okay? So that shaded region will be the rejection region. If it's a right-tailed test, that will be a rejection region. And if it's a two-tailed test or something that says not equal to, then your rejection region is split between both sides, okay? This will become very clear shortly. Now, this is for if this is method one. This is if you're drawing a rejection region, okay? You calculate your alpha. You know where they're at, right? You know where those little areas are. If your z-score falls into one of those rejection regions, you would have to say, I am now rejecting, the null hypothesis. If it falls in the other region, you can go, okay, then I can fail to reject. Now, what's good is the second thing I'm going to give you, okay? Because I'm not going to make you draw this on your final, okay? There's a thing we're going to use called a p-value, okay? Once again, here's your rejection region. It's in your book. It's on all that right there. So p-values, here they are. Biggest thing you need to remember right here. Because I do not give it to you on your final. You need to remember that. Okay? The p-value is the probability of obtaining a sample statistic as extreme or more extreme than the one observed in the data. When the null hypothesis is H of naught is assumed to be true. Procedure, conclusions for p-values. And it will be this way through every single one of the tops we use. Sigma known, same thing. Sigma unknown, same thing. Proportion, same thing. Every p-value will go with this right here. So if you got it memorized once, you got it memorized the whole time, or put it on your note card. So if the p-value is less than or equal to that alpha, remember that little 1 minus c? Okay, you reject. If it's greater than, you fail to reject. Okay? Don't make it harder than that. I'm about to show you exactly how to do it. So don't freak out. Let's do some examples real quick. Just once again, because it's important. Do that one real quick and see if you can't figure it out. I'll give you about a minute. What I want you to also tell me is once you get this one done, is if this is going to be a left tail test, right tail test, or two tail test. Manufacturer of potato chips would like to know whether its bag as filling machine works correctly at the 401 gram setting. It is believed that the machine is underfilling the bags. A 42 bag sample had a mean of 394 grams. Assume the population standard deviation is known to be 21. A level of significance of 0.05 will be used. State the null and State the null and alternative hypothesis. Sorry. I'm a little bit of a tongue twister at this level of the game. Am I dealing with proportion, mean, or variance? Mean, kind of a giveaway is like look what chapter we're in. Okay, it's gonna be mean. So if you're putting this down, where would I put a mean at? And what symbol would I be using? Mu. If I put mu here, where else would I put it? In the bottom. Going with what you know about the null, which is always at H sub 0, H sub naught, which you'll hear some people call it. What has to be the next symbol I put down? Equals. It has to be equals, right? I mean, that's a given right there. I mean, let's be honest, would you get that right on your assessment? No, but I'd give you a point. You're not like, hey, good job. You got a point. But now what? The mean, the population mean is equal to what though?
Or 401.
Very good. It's the 401. Be careful. They're going to give you a lot of information. Okay? A lot now. Well, that 401 can also go where? On the bottom. Once you decide the 401, remember, everything has to match. Mu has to match. The 401s have to match. You got an equality statement. I'm not going to do a hypothesis and go, hey, I think the mean, they say the mean is equal to 401. Well, I think it's 403. That's not the test. You're testing their claims, okay? If you want to do something else, fine. You run your own statistical problem, run up to your data, and then someone else can come behind you and go, here you go. And there is sometimes where people will do a statistical study and say, I think this. And then they do a p-value and they find out I was wrong. Okay, so that does happen, but this is not the case in this scenario. But now what? Less than, greater than, not equal to.
Less than,
Where are you getting it from? What word?
underfilling.
Underfilling. Right there, it says underfilling. Here's a question. What if I said overfilling? What if I said underfilling or overfilling? Not equal to. Be careful about that, okay? Because it may say that. Underfilling or overfilling is saying, hey, I think this thing is going like haywire. It's not doing anything right, so it's just not equal to at all. Okay, so be careful about that. Well, now what is it? Is it going to be a left tail test or a right tail test? Left, exactly. One little hint, it'll help you out. Do you see the alligator mouth? Alligator always eats what's larger, right? Where's it pointing? Pointing that direction? Where's it pointing? To the left. So it's a left tail test. Tell my intermediate officers, I go, hey, he's eating this direction he's pooping. Follow the poop. Okay,